Okay folks, you're gonna have to pardon the noise. K1GMM Steve in Vermont, and what we are looking at is the satellite antenna I'm using. I'm gonna do a walkthrough on this, and I will, when I have time, I'll post a parts list and a build plan for this. This is the 3-element quad with a 7-element UHF Yagi 2-meter quad, 7-element UHF Yagi built into the center of it on 1/2-inch PVC. Now let's get down to the meat of the situation here. Okay, I have azimuth, elevation, and pitch rotators on this. It works freaking slick. 1.5-inch PVC. Okay, these are couplers. There's no coupler here. This is actually a sleeve that to keep water from getting into the joint. All right, so the joint is actually inside this. All right, this is just plastic I have wrapped around it with shoe goo, silicone type stuff, to prevent water from getting into the joint where the entire antenna turns. This is the azimuth rotator. So 12-volt DC motor, sleeve fit into here. These are set screws to hold the motor in place gently. You don't want to crank them down too tight. And then I have a 1/2-inch piece of copper with an end cap soldered on with a 6mm stud sticking out of it, which is then coupled. That goes into a what's called a steel sleeve bushing, and I'll show you a picture of that in a second, with 2 set screws that I drill and tap, and that goes onto the motor. Crank them down, and that's the drive shaft for this piece. Now this whole thing goes like this. 300, so you can go more than 360 degrees around. This is the azimuth rotator. Okay, into a 1.5-inch PVC T. Another motor drive sits in here. That has another half-inch copper tubing for a drive shaft, which goes down through and comes out right here. Okay, now you're asking me, why did I use copper tube for the drive shaft? Here's the reason why. You can get go-kart bearings that will almost perfectly fit into a 1-inch reducer, and they have a 5/8 hole, 5/8 center ID, and about a 1-inch OD. Actually 1 3/8 OD, which is the size of a 1-inch reducer, which goes into the 1.5-inch PVC. So I take a Dremel tool and I grind out a little bit of the inside of the 1-inch coupler, and the go-kart bearing goes right in there, and the drive shaft comes out. So it's basically a thrust bearing, and then that comes into the T. This is a 3/4-inch T, and I'll explain the reason why I did this, which is pinned to the drive shaft. So this goes like this, but when the antenna is upright, it goes in elevation, and it will actually spin a full 180 degrees. You could spin it 360 degrees, but you'll tangle the coax up. So this will actually follow a pass all the way up and over if you wanted to do it like that. I don't. I just turn the antenna once it's at apogee and then follow it back down. This is a 3/4-inch T. Okay, I made bushings using a bench grinder for a 5/8 plastic rod you can get off of Amazon. So that rod comes in, I drilled out the 1/2-inch PVC boom to 5/8. This rod goes through this and free floats in here. This is the pitch rotator. And what this does is it changes the pitch of the antenna, which you need because of the varying polarization. A lot of people run 2 antennas. This is like 2 antennas built into one. So you have an additional motor drive here. It all runs through Cat 5. Cat provides Cat 5 cable to the shack, provides all the energy for the motors. So this 1.5 inch PVC, a couple end caps. This is that's the sleeve bushing right there. And then I tack weld this plate. It's nothing but an L bracket, like a corner bracket. That's a corner bracket as well. So tack welded that to the sleeve bushing. This goes onto the shaft of the motor, comes up here. This is a piece of cutting board, plastic cutting board, with a couple stop nuts with bolts, and then this screws to the boom. And when this motor turns, it tilts the pitch, and it'll tilt it 45 to 50 degrees each way. So you're never out of it because of polarization changes on the satellite. Cat 5 basically comes up into here, and that goes to a switch box in the shack, which has 3 double pole, double throw switches for the rotators. Okay. You're asking me, why did you paint it white and gray? I'll tell you why. Excuse me. That is the CCTV camera. This is the camera that I use to look. I pull it up on the screen in the shack, and that looks at the antenna, which is up above the J-pole there. It sits up there. It's about 20 feet with a push-up pole. It survived 70+ mile-an-hour winds the other day. I can't believe it. And the reason why I paint it white is because the camera is night vision capable, so I can see it at night. Now what I found was, if you're going to run pitch, right, it's very difficult to see how the antenna's pitched on night vision unless the elements are white. So I just dropped it down and I painted the spreaders white and the base element white on the driven element. So when I look at it in the camera, it's going to glow, like white glows. It's like there's a light on. This is sort of invisible. And what I did was I painted the coax white, the pigtails, because you can easily lose track of how many turns you go around, and I can see when this is wrapped now with it white, because this doesn't really show up on the camera. So this white will overlay on the post, and I'll see it disappear, and I'll know that I've gone too far in one direction. I'm starting to wind the coax up. So there you go. I think that's it in a nutshell. Yeah, it works great. All right. Catch you all later. K1GMO.